Chapter 5, Cost, Volume, Profit Analysis, and Breakeven Points. The reason you're learning this chapter is because in the future, you guys are going to be business manager, and you need to understand that business exists for a reason, which is to make profit. So therefore, you need to understand the breakdown of profit. You need to understand what impacts profit. So today, that's why we're learning CVP analysis, cost, volume, profit analysis. And there are some assumptions that we have when we're dealing with cost, volume, profit analysis. So the first assumption is that selling price is constant. So what that means is that it doesn't matter how many units you're producing, your selling price will be the same price. You're selling at the same price. The second assumption is that cost is linear, and costs are classified into two parts, fixed costs and variable costs. So fixed costs are costs that remains constant over the time period. So what that means is that fixed cost does not depend on the quantity produced. And the example that I gave you are rent, property tax, salary, etc. So it doesn't matter how many units you're producing. You could be producing 0 units, or you could be producing X amount of units. You're still paying that fixed cost each period. You still need to pay your rent every month. You still need to pay your salary every month. Doesn't matter how many units you're producing, you still have to pay those. That's fixed cost. Second type of cost that we have are variable costs per unit. So variable costs per unit are costs that are directly related to the production of the goods. So the example that I gave you are direct material, direct labor, sales commissions. So every time you sell a unit, these are the costs that are directly related to that product. And what we're assuming is that the variable costs are constant. So it doesn't matter how many units you're producing, you're still paying the same amount of variable costs for each unit. So those are the two main assumptions that we have. Next, we're going to talk about the components of profit functions. And what you need to know is that profit equals to total revenue minus total cost. And total revenue is defined as selling price times quantity. So that's your total revenue. And then your total cost, there are two components to total cost. We have the variable cost component, and then we have the fixed cost component. So fixed cost is just a dollar amount, just a fixed dollar amount. There's no calculation there. And then variable cost, total variable cost. Total variable cost is your variable cost per unit times quantity. And when you add total variable cost with fixed cost, that's your total cost. Total cost equals to fixed cost plus your total variable cost. And profit is just the difference between your total revenue minus your total cost. And when we're looking for the break-even points, we have 3 break-even points. First break-even point is break-even point in units. Second break-even point is break-even point in dollars. And the last one is break-even as a percentage of capacity. And the concept that you need to know of break-even is that break-even point is basically when your profit equals to 0. And break-even in units is basically the quantity produced when your profit equals to 0. When we look at the break-even diagram here, on the x-axis we have the units sold, we have the quantity on the x-axis, and on the y-axis we have the dollar amount. And from the diagram you can see that we have 3 graphs: total revenue, total cost, and fixed cost. We're going to look at the total revenue first. So the total revenue is the green line, and the total revenue function is price times quantity, P times Q. So when you look at the equation, total revenue equals P times Q, we know that the y-intercept equals to 0. Because X is basically your quantity, and then your P is your slope. And then our y-intercept is 0 because we don't have any y-intercepts. So therefore, total revenue is basically a line with positive slope, and it starts from the origin. The second line that we're going to look at is fixed cost, the red line in the diagram. So fixed cost in the diagram is $10,000, and that fixed cost is constant. So fixed cost is the same amount. Doesn't matter how many units you're producing, you're still paying fixed cost of $10,000 per period. So that's why you see a horizontal line. So the horizontal line represents that the fixed cost is independent of your quantity. Doesn't matter how many quantity you're producing, your fixed cost is still $10,000. That's the second graph. The third graph that you see is the total cost functions. And we know that total cost function has 2 components, fixed cost plus your total variable cost. So fixed cost is just your constant $10,000. So therefore we have 10,000 plus VC times Q. So Q is basically your X, and then VC is basically your slope, and then 10,000 is your y-intercept. So therefore when we're graphing the total cost function, the total cost function will start from the y-intercept of $10,000. So the total cost function will have the same y-intercept as the fixed cost, because both y-intercept are at the $10,000. And in most cases, your variable cost per unit will be less than your selling price, So therefore, when we're drawing the total cost function, the slope of the total cost function will be less than the total revenue function. So therefore, when we're drawing the total cost function, we're drawing a line with a flatter slope. Once we understand these three graphs, then we look at the break-even points. So break-even point is basically the intersection between your total revenue and your total cost curve. Because break-even point is the point where your profit equals to zero. When your profit equals to zero, that means your total revenue equals to total cost. So the intersection between your total revenue and your total cost function is your break-even point. And at the break-even point, if we look at the x-axis, that's your break-even point in units. So if we look at a diagram, our break-even point in units is 5,000 units. So that's your x, your quantity. Your quantity is 5,000 units. That's your break-even point in units. And when we look at the y coordinates of the break-even point, you will find your break-even point in dollar amount, which is $25,000. And that's your break-even point in sales dollar. So x-axis is your break-even point in units, and your y-axis is your break-even point in dollar amount. And why is the break-even point in units important? Is because it tells the firm how many units they need to produce before they can start making a profit. So if we look at the break-even point in units, anything to the right of the break-even point, anything to the right of the break-even point in units, the total revenue will always be greater than total cost. So therefore, anything to the right of the break-even point in units, we're making positive profit. Similarly, anything to the left of the break-even point in units, our total revenue is less than total cost. So the green line is less than the purple line for any point to the left of the break-even point in units. So therefore, anything to the left of the break-even point in units, the firm will be losing money. They have a negative profit.